Hello everyone, I am Mr. Ashok Kumar from VTU and AKLC. So in this particular video I am going to explain you about the project profiling Apache IO query from runtime logs. So I am not going to get into details about how we are going to implement this particular project or what are the efforts we are going to put in to implement this particular project, something like that. So all I am going to explain you in this particular video is the abstract idea about what will be done in this particular project, rather than concentrating on how we are going to implement it. So we will only focus on what are we going to implement it. Okay, so I request all of you people to go to your project coordinator and explain this particular project in the same way like I do in this particular video, and any questions they ask you, please reply back saying that you need 1 or 2 days of time to answer those questions, because you are still learning this particular project and you are not a master of it. Okay, so and all those questions asked by your college project coordinator should be redirected to me to this particular number, or you can email me typing all those questions in a notepad and send it across to this particular email address. So I'm going to reply back with the answers to those questions asked by your project coordinator, and then you can reply back with those answers. Okay, so let's get into this. So in this video all I'm going to walk you through is about quick facts about this particular project, followed by the prerequisites that you need to know before understanding this particular project, and then the existing system, like what we had before and what was the problem of that particular system we are facing currently, and what is that we are going to introduce in our project, and the advantages of the system that we are introducing in our project, and at last hardware and software requirements we need to implement our project. So let's get into the quick facts about our project. So the meaning of quick facts is that at any point of time you should be ready with the answers for some of the questions frequently asked by your college lecturers. Okay, so I'm going to put on some points here that you should be remembering throughout your project career. Okay, so the first thing that you have to remember is the base reference. Like, where did you get this idea from? Like, where is the idea, what is the reference paper you are using to implement this particular project? Okay, so and the second thing is domain, in which particular domain you are going to implement this particular project. Okay, and the third thing is the platform, so where you are going to implement this particular project. And the fourth thing is the lines of code, so how many lines of code are you going to write in this particular project, and the database used, so what amount of database are you going to use in this particular project. Okay, so like this various questions will be asked by your colleges at any point of time, so answers to these questions should be ready. So let me answer these. So the base reference, the idea that we got to implement this particular project was from an IEEE 2016 paper. So it's a transactional paper, so it's the latest IEEE paper available, that the current IEEE paper we are going to implement. So obviously it will be an added weightage to your project work. Okay, so the second thing is the domain. So the domain of this particular project is the big data. So big data will be the domain we are going to implement. I mean our project comes under the domain big data. So the platform that we are going to use to build our project will be Hadoop platform. So Hadoop is a platform, I'm pretty sure that you people wouldn't heard about this term Hadoop. Even though you would have heard about the term Hadoop, you may not be an expert in that. Okay, so just remember the name Hadoop. So it's a platform for developing big data projects and various analytics on that. Okay, so our project comes under this particular platform. Okay, and the lines of code, we are going to write around 3000 to 4000 lines of code in this particular project. So if you want to compare our project with any other institute project, I would like to say that, so any other institute project would be implementing a project in around 1000 lines of code. So you can compare that. So you can check with your senior project, or any of your friends doing in any other institute project and all. So on an average, a VTU student will be writing around 1000 lines of code, or 1000, sometimes 2000 lines of code to complete his final year project work. But in this particular project, we will be ending up writing 3000 to 4000 lines of code. That means we are pretty safe, and we are doing more than what VTU is actually asking us to do for. Okay, so that doesn't mean that the project is complicated. So don't think that in that way. Okay, so each and every lines of code you are going to write will be given a justification. Okay, so the database we are going to use. So the reason why I added this particular point is because VTU has a rule. So we are not supposed to use more than 20% of the database. So there is a restriction on the amount of database that we can use. We can use only 20% of the database. So to be more clear, so you are not supposed to use more than 20% of relational database. Okay, so you can say that you are using 0% of relational database in your project. Okay, so you are 100% safer side in this particular criteria. So we are not at all using a relational database. So we are into a big data domain. So we don't need SQL, we don't need MySQL. I mean, we don't need any relational data here. So it's 0%. Okay, so these are the quick facts that you need to remember about this particular project. Okay, so let's continue. So in this particular slide, I'm going to explain you about the prerequisites about this particular project. So yes, before you understand about this particular project in detail, you need to get some basic idea about some important prerequisites. So to mention them, I would like to say you need to have some basic idea about 3 things before you get into the project details. Okay, so number 1, you need to know something about big data, and number 2, you need to know something about Hadoop, and number 3, you need to know something about Hive. So very basic details about these 3 things you should be having in your mind before you understand about our project. Okay, so I'm not going to explain you in details about these terms here, because this is just a project abstract synopsis explanation. So however, do not worry, because the detailed explanation about each and every these topics will be given in the project classes. Okay, so let's get started by one by one. So then the first one, big data. So what you mean by big data? So as the name itself indicates, data of huge size. So data which the processor cannot handle it in a simple way, data which we cannot analyze it in a simple way. So something which is of huge, we call it as big data. So something, the fact says that 90% of the data has been collected over the past 4 years. So that means from the start of the year where we started to collect the digital data, say for example from 1945 to 2012, we have collected only 10% of data, whereas from 2012 to 2016 we have collected 90% of the data. So that's the exponential growth of data that we are seeing in the recent years. So obviously, so in future we are going to see more and more amount of data. So that's the future. So becoming a data scientist, so it's one of the heavily paid job in the current market, data scientist, right? So processing big data, how will you handle this huge amount of data? What are the technologies and available for analyzing this big data? Okay, so let's come to the second thing, Hadoop. Hadoop is one such solution to process that big data. So to explain it more clearly, so whenever you hear this term Hadoop, 2 things should be coming into picture. Number 1, Hadoop is a platform sorry. So Hadoop provides you the storage space, and number 2, Hadoop provides you the processing power. So these are the two things provided by Hadoop. So what do you mean by Hadoop? So Hadoop is both a platform and a framework. So remember, Hadoop is both a platform and a framework, so which provides storage space to store the data and processing power to retrieve the data. So in other words, I can give an alternative name for this, so focus on this. So the storage space capability provided by Hadoop, we call it as, you know, HDFS, whereas the processing power capability of Hadoop, we call it as MapReduce. Okay, so I'll make it more clear in a minute now. So you know, the meaning of HDFS is Hadoop distributed file system. So this is the storage medium where data will be stored in Hadoop. So MapReduce is the processing model, it's the programming model, so it's the processing power within Hadoop. So basically data will be stored in HDFS. To process the data within HDFS, we write MapReduce program. So that's how Hadoop works. So let me make it more simple, listen to me carefully. So inside Hadoop, in Hadoop, you know, life cycle, we store the data in HDFS. We retrieve the data using MapReduce program. That's it. Okay, so let me give you more example now. So HDFS, Hadoop distributed MapReduce, sorry, Hadoop distributed file system. So what do you mean by Hadoop distributed file system? So the meaning of Hadoop distributed file system. Okay, so I will be requiring, you know, some diagram to explain you more about Hadoop distributed file system. So okay, so I will look at this particular diagram. I will be giving you a particular use case. So you have to copy a file of size 1 GB into a laptop whose, you know, data rate, transfer rate will be 2 Mbps. Okay, so what will be the time taken to copy this particular file into this laptop? So the answer will be pretty straightforward, because, you know, it takes you know, 1 second to copy 2 MB, because the transfer rate is 2 Mbps, 2 MB per seconds. Okay, it will take 1 second to copy 2 MB. Then how many seconds will be taken to copy 1 GB? So 1 GB divided by 2, 5, so 0.5. So it will be taking 500 seconds to copy this 1 GB of data into this particular laptop whose rate, data transfer rate is, you know, 2 Mbps. So if you convert this 500 seconds into minutes, it will be 8.33 minutes. Okay, so this is the, you know, traditional problem. So so now the thing is, you need to reduce the time taken, so you need to speed up the process. So what are you going to do? So how will you speed up this particular, you know, data transfer you know, rate? So the solution to speeding up this particular data transfer operation will be you know, using one of the solution will be using 5 different laptops as shown in this particular you know, diagram. Okay, so rather than copying 1 GB into one machine, what I'm going to do, I'm going to partition this 1 GB file into 200 MB into 5 files like this: 200 MB, 200 MB, 200 MB, like this. This is the first, this is the second, third, fourth, fifth. So entire 1 GB file is broken down into 5 pieces whose, you know, size will be 200 MB each. Okay, so each of those pieces of data will be copied into different laptops at the same time. I'll repeat, at the same time, meaning concurrently. Okay, so the time taken in this particular, you know, scenario will be 200 divided by 2, it's 10, it's just 100 seconds. Okay, so if you convert this 100 seconds into minute, it will be 1.66 seconds, sorry, minutes. So remember, all these 5 laptops will be operating parallelly. So overall time taken will be still 1.66 seconds, right? So compared to the previous approach where it took 8.3 minutes to copy 1 GB file, in this new approach it took only 1.66 minutes to copy 1 GB file, the same amount of data. Okay, so this is the core concept, this is the basic idea about HDFS. The HDFS also works in the same way. If you upload a 1 GB of file to Hadoop, what will Hadoop will do? Hadoop will first break down that entire file into small pieces, and each pieces will be copied down into different nodes. Okay, so to speed up the process. So that's the reason why we call Hadoop distributed file system, because the data will be stored in a distributed manner, not in a single machine. It will be stored in a distributed manner. So that's the concept of HDFS. So I think that's more than enough to as a beginner you need to know only these things as of now. So more detailed about HDFS and how to set up HDFS, all those things will be taught at later point of time. Okay. So now that you know about HDFS, the data will be stored in a distributed way. So how will you retrieve them back? Because the data will be stored in a different nodes. So to retrieve them back is not a easy job. So you cannot simply enter a single command, or you cannot instruct it using a single line of program or something like that. So to retrieve the data and to process that data stored in HDFS, so Hadoop has come up with a processing power called MapReduce programming model. So using MapReduce, so we are going to write an entire a program, so a very big program just to retrieve the data stored in HDFS. So basically you are going to write 3 programs for retrieving a simple data in HDFS. So you are going to write a mapper program, you are going to write a reducer program, and you are going to write a driver program. Okay, so don't worry about what you mean by those mapper program, reducer program, and driver program and all those things and all. So just remember that MapReduce is a programming language using which we do lot of programs. Why do we write lot of MapReduce programs? For retrieving the data stored in HDFS and analyzing the data stored in HDFS. Okay, so that's why we use MapReduce programming model. So this is in contrast to our traditional Oracle and MySQL. So you can compare Hadoop with traditional Oracle and MySQL. So even Oracle also provides the storage space, and it also provides the processing power. So whereas the storage space in case of Oracle will be your local hard disk, C drive, program file, somewhere the data will be stored, and the processing power will be SQL. So to retrieve the data stored in Oracle, you will be writing SQL query. Just like that, to retrieve the data stored in HDFS, you are going to write MapReduce programming language. Okay, so that's about Hadoop. So now that you know about big data and Hadoop, so to give a brief overview about IEEE, so I can say that IEEE is it's a MapReduce framework. So in simple words, what I can say is, using MapReduce you are going to write huge amount of programs to perform analytics on the data stored in HDFS. But rather than writing huge amount of data using MapReduce program, you can write a single line, or you can write a very simple queries using IEEE. Okay, so to simplify that MapReduce programming job, this IEEE came into picture. So IEEE basically will take form of SQL like syntax. So using that SQL like syntax, so you are going to write a 2 to 3 lines of queries, and you will be giving it to Hadoop framework. Okay, so what Hadoop frameworks will do, Hadoop frameworks will convert that IEEE queries, and it will automatically generate the MapReduce program internally. Okay, and it executes that MapReduce program in HDFS. So basically the end user will be writing the IEEE queries, HIVE, end user will be writing the IEEE query, and the Hadoop framework will be creating MapReduce programs which will be executed on HDFS to retrieve and analyzing the data on HDFS. Okay, so this is all you wanted to know about IEEE at this particular point of time. Okay, so now let us come to our the project abstract explanation. So the existing system of our particular project happens to be Apache IVE, so which I have given an introduction to it few minutes back. So Apache IVE happens to be our existing system. So to define Apache IVE formally, so I would like to define it as follows. So I would like to say Apache IVE is a popular data analytic extension to Hadoop MapReduce framework. So Apache IVE is a popular data analytic extension to Apache Hadoop MapReduce framework. So it's basically written in the SQL-like syntax. It's not SQL. The syntax of writing IVE queries is SQL-like, but not SQL. Okay, don't get confused over there. Okay, so the SQL-like language makes it a convenient alternative to hand-coded MapReduce program. So what I meant to say by the second point is that, so rather than writing huge amount of MapReduce programs, so the developers can focus on writing simple SQL-like IVE queries. Okay, so this happens to be our existing system to our project. I mean the system that is already existing. So we are going to do a project something related to this. Okay, so we need to revolve around this particular existing system, and we need to find out the disadvantage of this particular existing system, and then we need to propose a solution to this disadvantage of this system. Okay, so now let us see what is the problem statement from this existing system. So currently in the way IVE executes, so there is one particular problem that the developer and the users of IVE the users of IVE will be facing. Okay, so what is that problem? So IVE query, so there will be thousands of IVE queries that will be executed on a daily basis in a typical data analysis industries like hospitals, banks, stock markets, social medias, etc., etc. So that's a pretty less number. Actually it will be more than 1,000. It will be lakhs of IVE queries that will be executed on a daily basis. Okay, so whenever an IVE query executes, it generates a log file, log. It generates a log file which prints the information message inside that log file. Okay, so if you look at the synopsis that I have shared with you people, so this is how let me open that synopsis. So this is how the IVE log file will look like. Okay, so I'm pretty sure you cannot understand this log file as of now. Not an issue. So just remember that whenever an IVE query executes, it updates this log file about some information. Okay, the status of that query will be updated within this particular log file. Okay, and this particular log file will be 50,000 lines, 60,000 lines, sometime 1 lakh, 2 lakh, like that. It depends upon the number of IVE queries that will be executed. Okay, so that's how the current IVE queries will be executed. So let me put it in simple words now. So whenever an IVE query execute, it updates the IVE log file about the details about that particular query. Okay, so and there will be more than 50,000 and there will be sometimes more than lakhs of IVE queries that will be executed in a typical data mining industries. Examples: hospitals, banks, social medias, stock markets, etc. Okay, so the problem statement that we can derive from these many observations is that if you want to investigate something, if you want to debug something related to that IO query, the only information, where can you find this information about this IO query? If you want to debug, say for example about these 50,000 queries, what if you want to find some information about 2 to 3 IO queries? So you need to get into those IO log file, right? So but that IO log file will be around 60,000 lines. So you need to scan through the line number 1 to line number, you need to do a Control F search, do some, that's a pretty brute force approach and awkward way of doing it. So that's the problem statement, and you would end up getting nothing. So that's a pretty, really a big problem that as a developer will be facing. Okay, so let me technically frame a problem statement here. So I can say that developers has to walk through countless log messages to perform countless log messages or numerous keyword searches to find information related to say for example performance or any other debugging information. So I meant to say if a developer has to debug any IO queries, or if he wants to analyze the performance of the IO query, like how much time a particular IO query took. So say for example among thousands of IO query, you need to know how much amount of time did a particular IO query took. So you need to scan through that 60,000 lines of that IO log file again, so which is once again a very difficult task. Okay, so this is the problem statement that we have in the current existing system. Okay, so now coming to our proposed system, here I am going to tell you what are we going to propose to overcome the drawbacks that we saw in the previous slide. So as I told you earlier, we cannot learn in depth about the proposed system. So all we can understand is what are we implementing. We cannot understand how are we implementing this. Okay, so in simple terms I would like to say the system we are going to implement in this particular project is a profiling tool. So I am going to highlight this. So we are going to develop a profiling tool. We are going to give a wonderful name for this. So let us come up with a name at later point of time. So we are going to develop a profiling tool. So this profiling tool will be reading the log file generated by IO, and it will be coming up, it will be generating a wonderful reports out of those log files. Okay, it gives us wonderful information required to the developers from those log files. Okay, so that the developers, whatever information you need, any debugging related information or any performance related information or any comparison related information from one query to another query, or whatever information you need from the log file, everything you will be getting it from our profiling tool more easier than compared to the traditional existing system. Okay, so rather than going into that log file and doing a search from line number 1 to 60,000 lines, okay, so those people can simply use our profiling tool and they can get everything in ready. Okay, so that's the advantage of our profiling tool, and it will be having lot of commercial, and people can readily use our tool in any corporate industry, and that's the best part of our project. Like without any modification or enhancement, our project will be capable of giving potential to those corporate end developers. Okay, so let me technically frame a sentence out of this proposed system now. So we are going to build a profiling tool, so which builds execution profile of individual IO queries with the information extracted from the log files. So we are not going to miss any of the single IO queries, no matter if even if there are thousands or lakhs of IO queries, so we are going to build the profile for each and every single IO query, the performance, the execution time, the debugging information, each and every information related to that query, we are going to build it. Okay, so what actually you meant by an execution profile? Execution profile means the collection of all these informations, like the performance related information, and the time taken, and the amount of CPU used, and some MapReduce details, etc., etc. Okay, so this is the system that we are going to develop in this particular project. So the advantages of this project, so I can mention that number one, each and every individual queries will be profiled. Each and every individual queries will be profiled, so we are not going to miss any single queries. So each and every individual query will be profiled. And the second advantage is we are going to come up with some visualization tools. I mean, we are going to implement our project with some wonderful GUI, graphical user interface, so that it will be easy for the developers to understand what's happening with those queries rather than reading the text. So looking at the reports like charts or graphs or something like that, they will be getting a better idea. So we will be using some visualization tools like that. Okay, and the third advantages is that so the developer or any other people can compare the queries. They can compare one IO queries from to another IO queries, and they can come up with the conclusion, like which one is taking more time and which one is taking less time, and which query is performing better or something like that. They can compare one query with another. So these are a few advantages of our proposed system. There will be a lot of advantages that we can come up with during the development phase. As of now, from the synopsis, I mean from the IEEE paper, I can extract these three advantages of our proposed system. So coming to the last part of this particular video, so the hardware requirement and the software requirements. So coming to the hardware requirements, we don't need any specialized hardware to implement this project. So because this is a technologically intensive project, not an hardware intensive project. So a basic system with 1.6 GHz processor, and 4 GB RAM and 40 GB hard disk would be fine for us. Okay, these are some minimum configuration that we will be requiring in terms of hardwares. Okay, so in terms of software, you can also treat this as the technologies we are going to use. So this is very important. So I would like to divide these technologies we are going to use into two things, the front-end technologies and the back-end technologies. So in the front end, we are going to use some languages like HTML, CSS, so JavaScript, and we are going to use Bootstrap framework, and we are going to use jQuery framework in the front end. And in the back end, we are going to use Java and J2EE, and we are going to use Eclipse tool for this, and we will be requiring an Apache Tomcat 9. So apart from this, we will be requiring a MapReduce framework, so I mean Hadoop platform to be installed. So that's the most important thing. So Hadoop platform to be installed. So this Hadoop platform, we can either get it as a virtual machine. I mean we will be downloading it as a virtual machine from the internet. Okay, so these are the technologies that we will be using in our project. So that's it I had for this particular video. So just a reminder, any questions that your project coordinator asks you, just tell them that you are still understanding about this project, you haven't completely mastered it. Okay, so any questions that they ask, you will be requiring 1 or 2 days to answer them. Okay, so all those questions you should be immediately redirecting it to me on this particular phone number. Or the best thing I would be recommending you people to do is type all those questions in a notepad and send it across to this email address. So the advantage of sending me in an email is I will be typing the answers and replying you back, so that you can keep it as a viva, or at any point of time if you want those answers you can recall it. Okay, so thank you so much.